All right, so this is section 1.4. So it starts on page, well, the title is on page 29, but the actual lecture starts on page 30. And it's called Perimeter and Area in the Coordinate Plane. So most of what you're going to be doing today takes place on this grid. And when I'm done talking to you about how to do this, I will give everybody a sheet of graph paper so that you can plot things and do what I'm asking you to do. But until then, you're just going to watch me do it up here. Pay attention and ask questions. Are you with me? So, perimeter and area in the coordinate plane. It's really strange because as soon as you turn the page, there's no coordinate plane there. They're throwing something in here that doesn't technically belong to that title. But we're going to do it anyway. It has to do with naming polygons. You know what a polygon is? Does anybody know what poly means? Gon is, I'm not sure that means anything, but a polygon is a multi-sided, closed, two-dimensional figure. Okay? And that means you can't get from the inside to the outside without crossing a side. And it means that none of the sides are curvy. So they are entirely countable. They're all straight and you can count them. Now, that doesn't necessarily mean that you're always going around a nice neat corner around a kind of almost circular going around. I mean, we have polygons that look like this. That's a closed figure made up of straight sides. Has four sides. 1, 2, 3, 4. But because this corner right here, one or more corners, dives into the middle, it's called concave. You know the difference between concave and convex? You heard those words before? This is a concave, four-sided figure, which we call a quadrilateral. Okay? It's concave, and if you have something like a star, which I'm not very good at drawing freehand, but if you have something like this, can you see there's 5 corners that dive into the middle, that take off and point towards the middle of the figure, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides to it. So this is a concave decagon. Deca means 10. Dec means 10. This right here would be a convex because all the corners are pointing outward. All of them have to point outward to be convex. But this is a concave or convex. 1, 2, 3, 4, 5. Pentagon. Are you familiar with the word pent means 5? Have you learned that in previous courses? Can you count to 10 in Greek? That's what these are. Or Latin. They mix them all up. Quadra is Latin. Tetra is Greek. But we don't say tetragon. We say quadrilateral. We don't say quadragon. We say quadrilateral. We say triangle. Just dumb. Why are we counting angles on one of them and sides on all the other? Lateral is Latin for side. Gon is Greek for side. So get the languages all mixed up. The smallest, think about this, the smallest closed figure that you can draw is a triangle. And it must always be convex. Think about that. You cannot draw something like this that has one of the corners pointing in. You can't make that happen, right? You can with 4 sides, as you've seen, but you can't with 3. And you can't draw any polygon if it has to be made up of straight sides with just 2 sides. You can't get it closed up. So the smallest polygon is a triangle, and it must always be convex. Once you get to 4 sides, then it can be convex or concave. So we don't have a number for 1 and 2 because they make no sense in this context. The first counting thing that we do is tri, T-R-I for 3, and then quadra for 4, but it's triangle and quadrilateral, and then we go to gons. Pentagon, hexagon, heptagon, octagon, nonagon, decagon. 11 sides, which you don't show you in this picture. Oh, yes, they do. No, they don't. They leave 11 out. But if you had an 11-sided figure, it would be an decagon, because the number 1 in Greek is un. Just like uno is number 1 for men. So an decagon, or an decagon means 1 plus 10 gon. Nothing 11 gone. Do is 2. That's the word for 2, and so a dodecagon is 12 sides. And it goes on up from there. That's all the farther they want you to learn. They didn't bother to tell you 11. You'll notice in that table we just skipped. You probably won't run into it, but it's an undecagon. Anything bigger than that, you got a 20-sided figure. We're just going to call that a 20-gon. 20-gon. That's it. Okay? I think that's enough on polygons. Now we're going to get to the actual. If you can't remember those Greek words, you can go back to that table and look. Y'all can recognize concave and convex when you see it? I hope. Yeah? Okay. All right, let's take a look at what's going on in the perimeter and area box just above example 2 on page 31. Perimeter. Can anybody describe or give me a definition of the word perimeter without reading it? Yes. All the sides added together, because perimeter means how far you got to go to get around it, which means you add the sides. We already did that today on one of the problems, right? Okay. What does area mean? Space inside. Measured in what kind of units? Give me an example of a unit you would measure area in.
Centimeters.
What? Feet squared. Is that an area unit? Feet squared?
Yeah.
Yes. If you were trying to find the perimeter of something, what would you measure it in? Feet would go with the feet squared. Centimeters, meters, miles. Square thing or interior where you're going to paint something or cover something, that requires square units. You're counting up squares inside that cover it. Okay, good. I'm glad you guys learned that before. Now take a look at the formulas that they have for you there. It's not very hard, and I'm sure you've seen this before. Perimeter and area of a triangle that you're looking at right there. The perimeter is the sum of the sides, like you said. A plus B plus C. Add those together, you get the perimeter. To get the area of a triangle, you have to go 1/2 base times height. But it's very, very important. The 1/2 is important, but it's very important to understand that the base that you choose, and it could be any of the 3 sides, and the height that you choose must be perpendicular to each other. So in the case of the picture that you're looking at right there, the B, even though they used A, B, and C, the B they put on the bottom serves as the base. You just have to start with B. We could have used A or C so long as we drew the height from the opposite vertex to it perpendicular. Must be perpendicular to the base. Okay, for squares and rectangles, of course you add up the sides to get perimeter. Notice that when you have a square, you can find the perimeter by just taking 4 times S because all 4 sides are the same length. So S plus S plus S plus S is 4S. And the area is length times width. Since they have the same length, the length and the width are the same, it's S squared. S times S is S squared. That's why they have it written like that. Rectangle, it takes 2 lengths and 2 widths to get around it. And the length times width. Notice that whatever you choose in the square and the rectangle to be your base and your height, they're always perpendicular because it's right angle all the way through both of them. Just so that you understand, if you are going to try to find the area of a parallelogram, not a rectangle, we follow the same rules we do for triangles, and that is when you choose a base and a height, they must be perpendicular to each other. So if I have something like this, and it's a parallelogram, and I make this 10 and this 12, this would be 10 and this would be 12. Perimeter would be 20 plus 24, which is 44, right? Area is not 12 times 10. Area is 12 times that, whatever that is, and it's somewhat less than 10 because that's the slanty part. They'll either tell you that or let you count it, or perhaps you could draw it here, making a triangle. Maybe they'll tell you this and you could Pythagorean theorem it to find it. But they've got to be perpendicular. And here's the weird part that a lot of people don't understand, that they could do it this way too. You could let the 10 be the base if you wanted, but you would have to find the length of this segment here, which is perpendicular to the base, to use 10 times this. And that would also give you the same area as 12 times this, because it's the same thing. It's the same polygon. Okay. So bases and heights that you use for area must be perpendicular. All right. Let's see what we got going now. Take a look at example 2. It says, find the perimeter of triangle ABC, whose vertices are, so you would plot these. And that's what all your problems are going to start out with a set of points. You need to get them plotted. And that's why I'm going to give you graph paper in a minute. This is my graph paper. So I'm going to plot these. Negative 2, 3. Right there. That's A. B is 3, negative 3. And C is negative 2, negative 3. So I connect those to make a triangle. Oh, and it's so happy. Because we've got a right triangle. Which means that 2 of the sides we can count because they're right along with grid markers. You don't even have to do the distance formula on them if you don't want. You can just count these because you graphed it in order to figure out what you got to deal with. And you discovered, oh, good, it's a right triangle. So I just count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And use Pythagorean theorem on that, since I already know my 6 and 5. Which is going to be, if you think about it, Pythagorean theorem is going to be the square, that distance is going to be the square root of 36 plus 25. Which is 61. I think. Yeah, 61. Everybody good on that? 61 is not a perfect square. What's the closest perfect square to 61? Perfect square number closest to 61. 64, yeah? So this thing's going to be pretty close to 8, but a little less. What is it? 7 point. Okay, now let me see what the instructions say, how accurate we have to do. It just says find the perimeter. That's it, period. And so you'll notice down at the bottom, when they get all finished, they are going to add them together, and they're going to let that one be 7.81, and so they go to the nearest hundredth. How do you know to do that? You don't. Just give me something reasonable. If you want to go with 8, that's fine, because 1's pretty small. And then you add 5 and 6 and 7.81. You get 18.81. Perimeter. Okay? If they wanted you to find the area, since this is a right triangle, that's a very happy thing as well. They didn't say area, but if they did say area, you would just take 5 times 6. Because I have a base perpendicular to a height. In a right triangle, the legs can be the base and the height. You take 5 times 6, which is 30, but don't forget to cut it in half. The area would be 15 square units. These square units. There's 15 of these square units in there. You okay with that? Cool. The next one says find the area of triangle DEF whose vertices are these. I'm going to start over. Okay, so we start plotting again. You're going to do a lot of plotting of points today. It says D is 1, 3. E is 4, negative 3. F is negative 4, negative 3. Negative 4. 1, 2, 3, 4, negative 3. Oh, that's kind of nice. They're both in the same place. D, E, F. So if I connect them, I don't, whoops. If I connect them, I don't have a right triangle again, but I'd have at least one side that I can count. This one. This is where slanty, yep.
E is 4, 2.
Oh. D is 4, 2. E is
4, 2.
Are you sure? I'm looking at example 3. I have 4, negative 3. You have 4, negative 3? Yeah. I'm looking at example 3.
Oh, example.
Right. Okay, that's all right. Does it feel like I plotted those right? Okay. The instructions are find the area of DEF. Whose vertices are these? This would be an excellent base to choose, not just because it's at the bottom, because it's the horizontal one, right? So I'm going to count it. 1, 2, 3, 4, 5, 6, 7, 8. But I can't use either of these. First of all, I don't know how long they are. I could find out. I know my distance formula. I could find out how long they are, but I don't want those. I can't. My base and height have to be perpendicular. So you impose a height that meets those conditions. You start from this vertex, you go directly to the base so that it's perpendicular, and you count that. 1, 2, 3, 4, 5, 6. Area is 24. Do you see it? You see that the area is 24? You all doing the arithmetic in your head? 6 times 8 is 48. You got to cut it in half. Speak.
Can I get Gracie and Brinley McInnes?
Why?
They need to bring their stuff to the counselor's office.
You guys want your assignment? Yeah? Okay, because you're gonna miss the rest of the lecture. The assignment is, and you might all, well, I'll write this down right now, but I really, really wish you wouldn't get started on it, so I'm done with you. Because I'm about to show you something really cool and you need to pay attention. Okay, so, but everybody write this down so I don't have to read it twice. Are you ready to write? I'll wait for you. Okay, here it comes. 1 through 17 odd. 18 through 25. 27 to 33 odd. And 36. It's not a very hefty assignment. Pretty easy to do. Okay? So you two that have to leave, you can go. You know what to do. Hopefully they'll figure it out. Good luck. But you all understand how we had to impose our own height here? And once we had it, we just multiplied these two and cut it in half because it's a triangle? Deal. Okay, so that one wasn't too bad. Okay, example 4. Example 4 is if you think about, I mean, you guys are good enough at this, you seem to be absorbing this stuff pretty well. But this is ridiculously easy. It is a real life type thing, but it's really easy to do. Take a look. Example 4 says you are building a shed in your backyard. The diagram shows the 4 vertices of the shed, in other words, the corners of the floor. Each unit in the coordinate plane represents a foot. Find the area of the floor of the shed. And we're using this diagram. Yeah, they put the whole thing in the first quadrant out here. They put it all right up in here, and they didn't even use the axes to do it. They put it out here somewhere. Because they did that, and I can see a picture, I am not going to bother at all with the distance formula. So the bottom part, which goes from 2, 2 to 8, 2, is going to be, I can figure that out because they listed that, it's just 6. Right? And the height of it is just going to be 5. So the area is going to be 30 square feet. That's almost insulting to your intelligence. Now comes the part that's going to be cool. So pay attention to this because this is the end of the exercise. And example 4 was probably one of the easiest ones of all. But I want you to look with me, please, at the exercises on page 34, starting with number 17. 17 through 24, that you got to do that whole set, right? Is that what part of the assignment? This is harder than you think, unless you listen to me now. Because it's not in your exercise, it's not in your book. Just listen. To do that, it's all about that figure that you see above number 17. And that thing is scattywampus all over. It's all leaning this way, and everything's slanty. It's hard to count. I'm going to show you a secret that will help you a lot with this. Not every single length will you be able to use this on, but most of them you will. Anytime, folks, that you draw a slanted line that goes, I'll just draw one down here, that goes from corner to corner. I can't draw it straight because it's so slick. Just a minute. That goes from corner to corner to corner to corner to corner. Anytime you have a segment that does that, that goes right through the middle of your grid markings, I want you to look at what that is so that you don't have to use the distance formula in this case. Before I go on, let me show you. You've got a lot of those. For example, the distance or the line that connects F and A. Can you see how that connects corner to corner to corner? There's also, from A clear down to D is a corner to corner to corner one. Notice from E to C connects corners. So does F to B connect corners. So does C to B. B and C are connected through the corners. Ones that are not connected that way, the only one on here is A and B. They do not connect corners. It's a little too shallow. See it? In that case, if you need to know how long it is from A to B, you'll have to use the distance formula. But all of the other slanty ones that connect things like this, you can count. But you have to be careful because I want to show you something. I'm going to take one of those grid squares and really blow it up. That's a grid square. It's a square all the way around. And this is one of those grid units, and this is one of those grid units, right? 1 and 1. So how long is this one that connects it from corner to corner? Pythagorean theorem says that it is 1 squared plus 1 squared equals h squared. They call that for hypotenuse. 1 squared is 1. 1 squared is 1. Which means that 2 is equal to h squared. So the square root of 2 is equal to h. Does that make sense to you? This thing is the square root of 2 long. And to help you get a feel for it, the square root of 2's value is irrational. It's in your calculator, but it's approximately 1.41. It's about that. Not quite 1.5. So if you are talking about a city block and you want to know if you're going to save any time by going through the middle of the park or middle of the grid as opposed to walking along the sidewalks, you will save a little. It'll only take you 1.41 units, where this will take you 2. You don't save a lot. You save a little bit, about 0.6 units, right? But here's what I want you to understand. I can tell you right now, without using the distance formula, that this particular slanted line is 1, 2, 3, 4, 5, 6 root 2. I can tell you that right now because every one of these is 1 root 2. So if you are ever counting or have a situation where you have a slanted line and you want to know how long it is, but they connect the corners, which happens more often than you think. Going this way right here, I can tell you how long that is. 1, 2, 3, 4, 5, 6, 7, 8, 9 diagonals makes this 9 root 2 long. Just like that. And then you can calculate, you can take 9 times the square root of 2 and it'll tell you what that is in decimalized units. You know what I'm saying? That will save you a lot of grief on those rather than using the distance formula over and over. There's only one segment on there you'll have to use the distance formula on, which I pointed out. All the others can either be counted directly because they're horizontal or vertical, or you can count them as multiples of root 2. Okay, you clear? That'll save you a lot of grief on them. Okay, you have your assignment. We have quite a bit of time. You can get started on it. So let me know if you have any trouble. You may want to, since this is new and weird to you, what I just showed you, you may want to do 17 through 24 first. I don't require that your assignments go in the order that I assigned. If you want to do 17 to 24 first, that's great. Just start out 17 and then do it. And then if you want to come back and grab the smaller ones, the smaller number ones, that's fine. I don't care that they be done in order. So if I were you, I'd practice that right now, see what you can come up with. There you go. Hope you can do it.